Harris, we're so excited to have you tonight with our Bunker Hill Computer Club. So I am going to turn it over to you. We're so excited to learn all about the eclipse.
Awesome. Thanks, Catherine. How y'all doing today? So I created a couple like some course content that you can use to just teach about eclipses, planetary orbits, and then really understanding how like space works. As I was creating this, I learned a lot about how vast space is and like how much nothingness there actually is in space. And we'll take a look at it. I'm going to start with a couple slides that I created, just to explain the eclipse that's coming on April 8th and like how an eclipse works, and then like how there's partial eclipses versus like a total eclipse. And then we'll dive into some code. We'll be looking at a couple 3D models of planets and planetary orbits, and then we'll stop me as I go along if you have any questions. I'm wearing my NASA shirt as it is, talking about space and everything. So let's dive in. Let me share my screen. Can everybody see my screen all right?
Yes, thank you.
Yep,
Okay.
yep, Harris, we can see it. Yep.
Awesome. So what we're looking at right here is we're taking a look at we're taking a look at an eclipse. So the solar eclipse happening on April 8th, 2004. So everybody pretty much from like Texas all the way up to like Vermont, New Hampshire area, like there's just like a band through there, through America. We'll take a look at the image. Everybody will be able to see pretty much an eclipse, but everybody in America will have the ability, like the North America will have the ability to see like a eclipse, not a total eclipse, but partial eclipse as well. So like, let's start with the question of like, what really is an eclipse? So created this little animation, or not, this is not an animation, but a picture right here, just to understand like how it works. Definitely not drawn to scale, but let's take a look at this here. We have Earth, and then you have the moon. And so, the sun emits light through, and the moon blocks the light that's coming from the sun, and it creates a shadow. And naturally, when that shadow is created, that shadow is going to be a little bit larger than, or smaller than, the moon itself. And so, as you can see here, that small shadow is called the umbrella. So, or sorry, there's a typo here. That umbra, not umbrella. So there's the penumbra, which is the larger circle that you're seeing here, and that's where you're going to have more of the what's it called? You're going to have more of the partial eclipses that you see. So if us in Massachusetts, we're going to get like a partial eclipse. We're going to be in like the 90% area, meaning that like 90% of the sun will be covered. Whereas individuals that are further away, say such as like in Florida, will be in like the area of like 50%. And then individuals that are further north than Massachusetts, such as like northern Vermont and New Hampshire, they're going to get more of like 100% eclipses. And so we'll scroll down here and we'll take a look at the different types of eclipse. So you have like your partial, your annular, and then your total eclipse. So this one right here in the middle, it occurs. It's very, very infrequent, because when you're looking at it, you'll see that the moon doesn't fully cover the sun, even though it's in the middle of the sun. And that happens when the moon, its orbit, is a little bit further away from the Earth than normal. Normally, the moon it's close enough to the sun that it will cover the entire sun, and you'll just see the rays on the outside. And this is what we're seeing. This is what we'll see, like where you'll see a total eclipse, and you're just seeing the rays on the outside. But with that middle type of eclipse, you'll see the sun around it. Are there any questions so far?
These are just great illustrations. Thank you so much. It makes it
Awesome.
so clear.
Awesome. So us in like northern New England, we're gonna see like a partial eclipse where we're gonna see like the moon is partially covered by the sun, and this is just natural. I mean, if you want to, you should definitely, if you have time, take a trip up north, and then you can see the full eclipse. And so if I scroll down here, let's take a look at like the actual like path of the eclipse through the United States. And what we're seeing here, this is this image provided by NASA. Um, you're going to see this darker band is the eclipse, the total eclipse area. So if you're in this area, you're going to be able to see a total eclipse. And then we see us down here in Massachusetts, we're going to be in like the 85% area or the 80% area. I know it's kind of small here, but right over here it's saying this is 90 and this is 85. So Massachusetts is going to be right in between there. Or actually, if I read this correctly, Massachusetts anywhere between 95 to 90%. So we'll see something that's very similar to like a total eclipse. But those individuals up north will get the full effect of the eclipse, and everybody in the continental United States will be able to see some type of an eclipse. And you can notice that by the different smaller bands as it moves forward. Questions about this so far?
This is so awesome. I definitely didn't realize the whole US would see some partial eclipse. So that is so cool.
Yeah, definitely. And another thing to note here is if you see this little globe on the right side here, let me see if I can make my screen larger. Oh, for some reason, okay, well, can't make the larger, but what we can see here on the left side of the screen here, you'll see the globe, and you'll see where the eclipse starts, somewhere over here in the Pacific Ocean, and then it crosses on through Mexico, and then crosses through the United States, and then goes all the way to the Atlantic, or Northern Atlantic, and then a little bit across like Canada, and then through the Atlantic. And note that how eclipses work and the orbits, that it doesn't just rotate all around the Earth. It's not like Europe's going to just get it because of just how the fact of how the moon and the Earth have to align perfectly with the sun. So it's quite rare for this to happen, like where we have a total eclipse. Last one that did happen in the United States was in 2017. And typically in the Earth, there's typically like a total eclipse total eclipses happen about every 1 to 2 years, because it has to be a full moon to occur. And so it has to be a full moon in combination with the fact that it also has to be where the moon aligns with the sun, and then also the Earth has to be in the proper orbit, or section of its orbit. So this, like, a phenomenon is quite special. So with that said, let's dive into some code and actually take a look at analyzing some models here. So let me restart my kernel here and let's start this up. So what we're going to do here is I've just changed over to a Jupyter Notebook, and I wrote some code so that kids can take a look at how planetary orbits occur and how imperfect many things are. Because what we'll see here is I'm going to make a little 3D rendering of the moon's orbit around the Earth here. And what we're going to see is that the moon's orbit around the Earth isn't 100% flat like that we would normally think, meaning, so what we'll see here is this is a 3D rendering that I can move around here. And what you'll see is first that the moon is roughly, or at most, about 3,000, actually I have the exact number right up here, I could just read it to you, 3,840 kilometers away from the Earth. So there's a lot of space between the two. And you should note that the moon is roughly like 1,700 kilometers, like its radius. So if you think of it, it's 300,000 kilometers in distance from the Earth. We're talking about like almost 300 or almost 400 times the space between the two, in distance from like the moon size to the Earth. And then the Earth is roughly like 3,000 kilometers as well. And then what you'll notice here is if I make this flat right here, you'll see that the moon, it changes like its orbit roughly about like 35,000 kilometers. Like it's not a flat orbit around the Earth. And that's why you're going to notice, one of the reasons why you notice when we go back to the slides here, that you'll see this band isn't like a flat band around the United States, kind of like if it was like one of those longitudes lines that are drawn around the globe. It's not equal because of how the moon's orbit rotates around the Earth. And so another thing to note that you might not see here is that it's never a perfect circle. So if I were to zoom out here, this one probably looks like a perfect circle, but it's never a perfect circle as well. But what you can see here is this all these imperfections create the rarity of this event that we're seeing today. And as we can see, we can rotate this around and we can see all the different types of angles of how this eclipse occurs. Any questions before I move on?
That's a really cool graph. So are you plotting the actual orbit?
That's a good question. So this is not 100% the actual orbit. Yeah, this is not to scale. What about the next graph that I show you will be to scale. This right here this is roughly the actual orbit. If we later on, I'll show you, we'll plot the orbit of the Earth around the sun, and then we'll add another planet and we'll see like the moon, or sorry, Mars as well, and you'll see a little bit like it's more relative. This is not to scale, not at all. Any other questions? And another thing I should note I want to correct is that like the distance that we're seeing here, that is to scale, but like the I want to say the size of the two orbs are not to scale. This moon being this size and the Earth being this size, we'll see as we move on, it will be a lot smaller. If there are no other questions, we'll take a look at it right now. So what we're going to see here is as I move down, I create another graph here. This is going to be a two-dimensional graph of the moon rotating around the sun. And so what we're going to see here is, and I don't even know if you guys can see this. Can you see this little tiny gray dot moving around?
Yes.
Yeah.
Okay, awesome. So this is drawn to scale. This is what it looks like. That is the size of the Earth. This blue dot right here is the size of the Earth, and that's the moon. And so now you can see, okay, what are the chances of this little tiny gray dot lining up with the sun, which would be theoretically, if you're looking at this on your screen, the sun would be somewhere in like probably like the next room, or actually two rooms away from where your computer is looking at right now, because it's like several million, hundreds of millions of kilometers away. And the chances of this little moon lining up and then creating a shadow on the Earth so that we can see a shadow of this eclipse. Now, if you think about all of those things lining up and happening, it's astronomically small. And now we're actually witnessing this event. And as we see, another thing to note here is this moon rotation around the Earth. I'm showing you this would be in like in real time, as if like these are the number of Earth days as the moon rotates around. And then you can also see like the actual moon rotations, like the number of rotations that the moon makes. So the moon makes roughly like 13 rotations every year. And so you might be saying, well, wait a minute, it seems like the moon goes up and down every single day, right? But how does it only make 13 rotations around the Earth? Well, we have to recognize that the Earth is rotating while the moon's rotating around us. So that's why it seems like the moon is revolving much quicker, because it seemed, if you weren't thinking about the other way, you'd think that the moon was rotating every single day around the Earth, but in reality, the Earth is just rotating itself once for every day that we have, and then we see the moon rotates as well. And that's why you can see the moon change in different locations as it rises and sets throughout our entire year. And then we also have like it creates different seasonal effects, and then also creates different tide effects throughout the year as well. Any questions about this?
This is so cool. Thank you so much.
No problem. I mean, I thought it was really cool how vast space is. Like there's just so much white space. And I thought when I first created this, I thought to myself, oh my gosh, like did I do something wrong? But I double checked my facts, and reality is that there's just so much space inside of space. I mean, what else would we call it? It just is what it is. It's space. So then the next thing I'm going to go here to do here is I'm going to scroll on down. We're going to create another 3D model. And in this case, what we're going to start doing is we're going to start looking at the sun in relation, or the Earth in relation to the sun. And so I'm going to start this right here. And so now what we see here is you see obviously this yellow orb right here is the sun, and then the blue is Earth. But you'll notice now these units are no longer in what's it called? They're no longer in thousands, they're in millions. So what we're seeing here is that this orbit is like more than 100 million kilometers with a radius more than 100 million kilometers. So the Earth is more than 100 million kilometers away from the sun. And like if we remember, the moon is 100 or 300,000 kilometers away from the sun, or away from the Earth. And so what we're seeing here is the vastness, because if I was to draw, or we could draw the moon in this image right here, we would see that it would like almost be, in reality, it would be like attached to this sun orb or this Earth orb, just by the simple fact of how vastly different the size and distances are here. Does that make sense?
Totally.
Yeah.
Yeah.
Yes, it does.
Yeah. So what we're seeing here is this whole thing. It's great to understand, because then now we can understand, like, if when this happens, when like the moon moves in front of this the sun, or in front of the Earth, to create this eclipse that we're seeing, and it's that little tiny ball that we're looking at above here. It's this little tiny ball. It's the chances of this happening are so small, and that's why it only happens between, in reality, the Earth sees about 5 eclipses a year. Now, a total eclipse only happens between once every 1 to 2 years. So this total eclipse once every 1 to 2 years, and it creates the rarity and the scarcity of it, but also to compound upon that, the moon is actually moving away from the Earth a little bit every year. So that's why the chances of it happening are decreasing a little bit every year. And that's that's something that we should also keep a note here. So this eclipse, we could probably figure out when the next one is going to happen, but it's probably going to be a couple more years until America sees another one. So let's take a look at this. Let's add another planet here. So if I wanted to, I can add Mars here, and okay, so now what we can see in this orbit here, I think I might have mixed up like the actual the angle of the orbits, but more specifically, we just want to take a look at like how different how much larger or further away Mars might be than the Earth, and then comparing the two. And what you'll notice here is that on this particular date, I think we set the date, or at the start of this date, we'll see that Mars will be over here, Earth will be over here when this does occur. And we can see right here, this date is starting 2001. January 1st, 2001. We could change that later, but we'll see that obviously planets don't always line up as well. So maybe another example, or another time, if the planets ever do align, we could also create another notebook explaining that phenomenon as well. But what we can see here, once we added Mars, we can see like now it's almost 200 million kilometers away. Mars is just 200 million kilometers away. So it's a little bit colder out there than if we were on Earth. Yeah. So what we have here is we have like Mars orbit with Earth orbit and with the suns. And so what we're about to do is we're about to move on and take a look at the how the eclipse occurs while we see a moon rotating around the Earth, and then with the sun as well. Any questions before I move on?
This is awesome.
Okay, so let's take a look at this, and let me clear this. So let's run this sample right here. Okay, so it's take a little second for it to start up. Okay, awesome. So what we're seeing here is we see the sun, we see the moon rotating around the Earth, and then this gray line right here, and once that lines up, we see the moon is in alignment with the sun and the Earth to create the eclipse. Now, one thing we should note here is none of this is drawn to scale, unlike the one above, unlike the 2D model that was above, because the Earth and the moon are 10 times larger than they should be. And then the sun itself is 100 times smaller than it should be. So you can probably tell it's way out of proportion. And then another thing to note here is this distance. If this was the sun right here, then the Earth would probably be in the next room over from where you're sitting right now. Because we're talking about millions of kilometers, hundreds of millions of kilometers here. So, but this gives us a great example of just the idea of how this eclipse works. So where this is the Earth, this blue orb moving around the sun over and over. It's rotating as well, and then we have a moon that rotates as well. And then the chances of America, North America, lining up and the moon lining up at the same time while it moves around the sun and the rotation of the Earth, those chances, and then we have ourselves an eclipse. And so you can see the scarcity, the rarity of it all, but also it's pretty cool to see how it all works. And this is all I have for you. This should give you a whole holistic overview and understanding of how eclipses occur and how easy it is to actually do this with a little bit of Python. And so feel free to take this notebook. I'll throw it up on GitHub and play around with it. And also I'll also add the slides as well. And I was just working with this all in my Grader Than Workspace, and making it quite simple for me to just jump right back and forth through my slides, as well to then go into my notebook and then to check out the code. Any questions before we close it out?
Hey, Harris, I don't know what I'm doing. I'm hitting the wrong button. The next you know, I'm off the meeting. I had to get back in. So
yeah.
I guess I finally did it right. But you mentioned about the moon is about 3,000 kilometers from the Earth. Yeah. At some point you mentioned that, and I just wanted to get understanding between that kilometers within miles. I'm more understanding with miles. How many miles? Like 3,000 kilometers. I just want to get an understanding of that, because I'm more in the miles than in the kilometers.
That's a good question. Let me figure that out.
Okay, with that. And then also you mentioned that you said that this full eclipse happens you said in the United States, I guess I hope I'm saying it right, every 2 years?
Yeah, so a total eclipse happens somewhere in the Earth 1 to 2 years. So it's not just America, so anywhere in the Earth.
Right. Okay, I see. Okay, so it won't be the same one every year. Okay, every 2 years, whatever. Okay, it won't be in the same position. Okay. See it. Okay. Okay, with that there. Okay, that's interesting. Very interesting. And then one last thing, when this full eclipse happens, does it affect the Earth in any way? Like, does it cause higher tides or any tides as far as high and low tides, or does it affect the Earth in that sense or anything when it has a full eclipse?
I mean, I'm not a an astrologist. I'm more of a programmer. So
Oh, okay, okay.
the best I can say, the best I can say
okay.
is I imagine it does, because I imagine that it does have an effect on what happened. Like the moon naturally has an effect on what the gravitational pull on what happens on the
Yeah.
Earth. So I can imagine
Yeah.
some things do change, but
Right. Okay. Okay.
I can't imagine it, or I can imagine it's probably going to be. Actually, I don't know. It's
Yeah.
going to be interesting to see. Yeah.
Right. Oh, okay. Okay. That's fine. That was it. I just
Yeah, to answer your original question,
Yeah.
so 384,000 kilometers equates to 238,000 or 239,000 miles.
Wow. 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 Okay. Wow.
Yeah,
Thank you. Thank you.
no problem. Any other questions?
Yeah, this is nice.
Yeah.
So we'll be able to download it from the GitHub?
Yes, yes. I will what I'll do is I'll throw it up on our Grader Than GitHub account. So just go to github.greaterthan.com or GitHub/Grader Than, and then you'll find it. It'll probably be under like Solar Eclipse. I haven't created the repository just yet, but it'll be under probably that Solar Eclipse 2024 or something.
Okay.
You're excited to run it, Dave?
Yes. And my friend Tom, who's teaching his grandson, who's in 8th grade, I'm sure he'll appreciate it too.
Definitely.
He's teaching him Python.
Oh, that's awesome. And Emily, you were saying like, I loved even as you went on here, it's like all the graphics were awesome. And I thought even though the last one was like out of proportion, it just gives a great, it makes it very clear as to kind of, what is happening.
Mm-hmm. Yeah. Yeah, it's amazing how vast space is, how much space there is out there. Yeah.
So earlier today, my wife Cindy, she asked me if I wanted to join her brother. This is the brother that's in the Republic of Congo. He's coming back for a month, and he has rented an Airbnb up in New Hampshire somewhere. I don't know the details. So we have to join him.
To watch the eclipse.
To watch the eclipse, right.
So that he rented the Airbnb. I've heard a lot of people, and I've also heard a lot of people say that like hotel rooms are booking up and, all those kinds of things in the Passage Hotel.
Okay.
Wow.
Yeah, it should be like, it's also quite short, like experience, because it should be around like 3 o'clock or 3 p.m. Eastern time, or Eastern Standard Time, for when the eclipse does occur. And like I can imagine there's going to be a lot of bookings or people showing up right around that time, and then yeah.
Because the last one in 2017 was like three hours. It was long. And this one is just minutes. So, I mean, it'll be interesting. It's a perfect time of day, though, in terms of like end of school and like, so that works out really well. I think the last one was in August, so no one was in school. So big thing.
Yeah.
Any other questions before I turn off the recording?
No,